Hi everyone, today we're going to be looking at justifying why a number is rational. And we talked in the last video about how to justify a whole number and some fractions. And now in this video, we'll take a look at some decimals and see how we can justify if a decimal is rational or not. So let's put our rational word up there. And you can see that ratio word in there again. So what we're trying to do when we're justifying these is we're trying to make the numbers into a ratio of two numbers. So our first example is 0.15, or if we say that in our academic language, it is 15 hundredths. And we are trying to make 15 hundredths into a ratio. I remember from 6th grade, if you think back, that you can make a decimal into a fraction by saying it academically. So 15 hundredths means 15 out of 100. Hey, look, we have a ratio of two numbers. So we change that decimal into a fraction. And then we always want to simplify our fractions in 7th grade because that's how we do it. And we're going to divide both by 5 in order to simplify it. So 15 divided by 5 is 3, and 100 divided by 5 is 20. So 3 over 20 is the justification for 0.15. Our next one is negative 1.7. If I say that number academically, it's negative 1 and 7/10. So we'll write that out, negative 1 and 7 out of 10. Okay, this is a mixed number now, and we need to change this into a ratio of two numbers. In this right now, we have the whole number out front. So let's make it an improper fraction in order to make this a ratio of two numbers. We have one group of the 10 pieces, so we do 1 times 10, and then we add the 7 in to get 17 tenths. And it is a negative 17 tenths. So we wrote our negative 1.7 as a ratio of two numbers. All right, one more example, 0.6 repeating. And I can't say that academically, but I'm going to tell you that any number that repeats, any decimal that repeats, is a rational number. You guys might remember from before that 0.6 repeating is 2/3, and that's obviously a ratio of two numbers right there. But we don't have all of our repeating decimals memorized as fractions, so the justification that we want you to use for this is just it is a repeating decimal, so it is rational. Except for let's spell repeating right. And there you go. There's our justification. I hope this helped with justifying why a number is rational when you have decimals.